Okay, so we have the following statements are equivalent for a polynomial f of x. We're talking about any polynomial f of x with a real zero, k. So k is known as a solution. Another thing you can call k is a zero. One reason they do that is because if you are talking about some polynomial, anywhere it is zero, okay, anywhere it hits the x-axis, it's actually a zero on the y-axis. So k is considered a solution or a zero. It is also called a root. Okay, those are three different names for the same thing. Solution, zero, and root. If k is actually a solution or a zero or a root, then you know that x minus k is a what? It is a
factor.
Factor, exactly. That's what we were talking about. It's a factor of f of x. When f of x is divided by x minus k, the remainder is 0. That makes total sense now, doesn't it? Okay. K comma 0 is actually a point, and that is the x-intercept. That's where it crosses the x-axis. So just kind of for kicks, let's look at this here and see if you can tell me what this was here. What kind of form of an equation is that?
That's the intercept form.
Of a quadratic, right? Well, this is basically the idea behind any intercept form of any polynomial. Because p was, or the p is like p comma 0 was your x-intercept, right? So if I know all the zeros or all the roots or all the solutions of my polynomial, then I can actually turn around and write them as factors and figure out the equation of my polynomial. So if I can find out where these zeros are, where it crosses the x-axis, I can come up with an equation to fit.
So would p equal k in that instance?
Yeah. Well, they're saying k is a 0. So one of these, k comma 0, we could call that k 0. We could call this p 0.
Like P or
call this
Q
q
or
0. Yeah, it's just a number. Okay. Sweetness, huh? All right. All right, let's whack that.